Hello, this is Nirmala Shenoy, and I'll be talking about our multi-route mesh tree protocol for data center networks. Talking about data centers and data center networks, data centers comprise of thousands of servers, and data center network is the backbone that connects the servers in a data center. So if you look at the challenges faced by data center networks, it's got to do with security, it's got to do with maintenance, it's got to do with energy concerns, and so on. So considerable research is being targeted toward DCN architectures and topologies to address these multiple challenges. Our research focus is to see if we can simplify the protocols and hence router operations considerably, and in the bargain address several of these challenges. If you look at networks today, they follow well-defined architectures and topologies. Data center networks in particular predominantly use a folded-Clos topology, which is very symmetrical. And in this folded-Clos topology, the popular protocol suite used is BGP, ECMP, and BFD. Our approach to routing in a data center network uses a mesh tree algorithm, which was invented by us, and our MR-MTP protocol establishes all possible trees from each TOR to the top tier spines using the mesh tree algorithm without forming any loops and without using routing protocols. MR-MTP thus replaces BGP, ECMP, BFD, UDP required for BFD and TCP required for BGP, a total of 6 protocols in a current DCN router. It can also offer customized security and significantly improved performance because of its reduced complexity, it's cost efficient and energy sustainable, it's auto-configurable, and requires low maintenance and troubleshooting. For these reasons, this technology is highly suited for defense data center networks and also for public data centers. Well, let us have a look at the protocol stack. MR-MTP replaces multiple protocols as just explained, and that results in the following benefits: reduced operational complexity, configuration needs, reduced troubleshooting, reduced management, cooling, equipment cost, etc. There is the protocol stack, a comparison between what you would see in a current DCN router compared to an MR-MTP DCN router. So what are the features of MR-MTP? All that it requires is a tier for the different routers in the different tiers. The TORs need a virtual IDs. We auto-derive this from the subnet addresses currently. The C code for MR-MTP is as small as 40 kilobytes. More information is available in these links. MR-MTP can be turned off to fall back to IP-based protocols, and several other advantages are there. So let us see how MR-MTP sets up routes using virtual IDs. So the TORs have a VID derived from the subnets. So you see 11, 12, 13, and 14. TORs advertise their VIDs, the next tier spines, request and get a VID, a sign which is an extension of the TOR VID appended by a port number, and the similar thing goes on to the top tier spines and they get their VIDs. So the routes are set up using these virtual IDs from the TORs to the top tier spines. Let us look at S21. S21 has got a virtual ID from all the 4 TORs. Similarly for S22, S23, S24. Let us now target how an IP packet gets forwarded between the servers. A packet from the 11 network to a 13 network. When it arrives at the TOR puts in his own header, and then based on the destination, virtual ID, and this VID table at the spine, the packet gets forwarded from spine to spine till it reaches the destination TOR, where the destination TOR will remove the outer encapsulation and deliver it to the server. No IP addresses were used, no routing protocols were used. That is the operation of MR-MTP, and it does all the forwarding. For our performance test, we took this two-port topology and four-port topology. We introduced 4 failure test cases, and here are some of the results. When you compare MR-MTP, look at the low convergence time compared to if you're running just BGP. And even if you include BFD, it is still not as good as MR-MTP. Same thing applies to the control overhead. Very low control overhead with MR-MTP. Same thing applies to the blast radius. Very low number of routers are affected. And last but not the least, the packet loss. Look at the reduced packet loss that you get with MR-MTP. So, given all these performance features, we have validated that MR-MTP is superior in its performance compared to the current protocol suite. What are the other benefits? The cost of the equipment will reduce significantly due to the hardware and software reduction. Energy consumption per router in the DCN will reduce significantly. Auto configuration, auto addressing will solve so many of the human error and configuration problems we face today. And this will have a multiplicative effect as the DCN size increases. And in an MR-MTP DCN router, because we do not use BGP, TCP, IP, we are circumventing or mitigating all the threats that can be posed against these 3 protocols. Thank you.